Imagine a planet where the surface is so hot that it could melt lead, a metal that melts at about 327 degrees Celsius. Imagine clouds made of sulfuric acid and an atmosphere almost 90 times denser than Earth's. This planet is our neighbor, Venus. But here's the mystery. How did a planet so similar to Earth become one of the most extreme worlds in our solar system? To understand that, let's go back billions of years. Early Venus may have had much more water than it has today. But Venus is closer to the Sun, so it received more heat. As the planet became hotter, more water evaporated into the atmosphere. Water vapor can trap heat, like a blanket around a planet. The hotter Venus became, the more water evaporated, and the more heat was trapped. More heat caused more evaporation, which caused more heat. This cycle may have pushed Venus into a runaway greenhouse effect. But where did the water go? High in Venus's atmosphere, sunlight can break water molecules apart. Lightweight hydrogen escaped into space, and over a very long time, Venus lost much of its water. Meanwhile, volcanoes released huge amounts of carbon dioxide and sulfur dioxide. On Earth, oceans can absorb CO2 from the air. That carbon can then react with rocks and minerals and become locked away for millions of years. This helps stop CO2 from building up too much. But Venus is extremely hot and has no large liquid water oceans today, so it doesn't have the same way to remove and store CO2. As a result, huge amounts remained in its atmosphere. Today, about 96.5% of Venus's atmosphere is carbon dioxide, helping push its surface temperature to around 465 degrees Celsius, hot enough to melt lead. And what about those strange clouds? They aren't made from CO2. Volcanic sulfur dioxide reacts with water and sunlight high in the atmosphere, forming sulfuric acid droplets. These droplets create Venus's thick clouds. But how do we know what's beneath those clouds? The Venera spacecraft helped reveal it. Soviet missions landed on Venus, and Venera 7 became the first spacecraft to successfully land on another planet and send data back to Earth. Venera 13 later survived for about 2 hours and sent back color photographs from the surface. And Venus has one more mystery. It spins backward. Most planets rotate in the same general direction as they orbit the Sun, but Venus rotates the opposite way. A full rotation takes about 243 Earth days. Why? Scientists have several ideas, including ancient impacts and long-term effects from the Sun and Venus's atmosphere, but there is no single confirmed answer. Earth and Venus are similar rocky planets and close neighbors, yet one became a blue world with abundant liquid water, while the other became a scorching world beneath acidic clouds. Venus shows us how dramatically a planet can change. If you enjoyed this video, make sure to like and subscribe, guys. I'll be back in the next video with another mystery or space topic. Until then, keep looking up.